Thank you. So I'm Aidan. I'm a PhD student at Durham University, and my research is looking at understanding and improving aerodynamic performance of wind turbines, specifically that have been affected by leading edge erosion. So why am I looking towards this topic? So offshore wind is obviously a rapidly growing market at the minute, and it's instrumental towards the drive for green energy, especially in places like the UK, where there's a large abundance of shallow coastal waters. So this is seen through the installed capacity of offshore wind increasing up to 10.5 gigawatts in the UK at the start of 2020, which is enough to power over 20 million homes. And then because of this, the levelized cost of energy, or the price that the operators will sell the energy at, has also decreased rapidly, and now approximately 2/3 the cost of electricity produced by gas turbines, so it's very competitive. But erosion presents a big barrier towards this continued growth because of developed from high velocity impacts of particulates such as rain. There's large costs associated with that. So first, there's a reduction in aerodynamic efficiency, which reduces the power output, and also blades need to be repaired and replaced, which means there's downtime of the turbines. So my research is looking at two methods. So firstly, there's this computational side, which has a high versatility and the ability to conduct a wide range of simulations and different inputs. And also a large amount of data comes out to be analysed to help understand why the changes are occurring. And then on the opposite side, there's an experimental approach, which has the ability to analyse physical specimens and measured levels of erosion in order to tune and validate the CFD model in the future. So an example of some of the results that have come out already have the power curves up at the top right there, which from simulation data. And that kind of shows the power output of a wind turbine over its operating wind speeds. And you can see there's this small difference between the clean and rough case here, and that generally correlates in an established erosion case like this to approximately 1% reduction in the annual energy production, which when considered with the profit margin of an operator of maybe around about 18%, would correlate to actually a 5.5% loss in overall profits, or for a single 8 megawatt wind turbine, that would be almost £500,000 lost over its lifetime, which is very significant. Therefore, I've worked with my project sponsors, who are Ersten and Siemens Gamesa, who are both leaders in their respective fields, to help develop the deliverables that we've got up here, which I'm working towards, to help maintain a profitable and more competitive market for offshore wind. Thank you.